right. Hey, everybody. Well, sure we will probably have a few people join us. So like last time, I was just going to go through the Test 3 review assignment. We just worked through some problems. Right now, there's only 3 of y'all. So before I get started, if any of you just have a question you want me to answer, you're welcome to speak up and ask it. And I'm glad to do that. Our test is just like normal. Everything's kind of the same. You can still use your notes. It's due by Friday. It opens tomorrow morning early. I'm going to send out another email today after this about test and everything. But I'm trying to think what else. But it kind of works the same way. So it really is great just to study through this review assignment because the problems are, not exactly, but very similar. So I'm going to go through most of them. I might skip a couple of them just because there's 2 different long division problems on the review assignment, but there's only 1 on the test. So definitely study both of them, but I'm just going to go through 1 of them for time's sake today. All right, so I'm going to share my screen like before. And once again, please feel free to ask me any question while we're working along, okay? Because I'll just be working through it. So let me do my sharing so I can get it going. Takes me just a sec. All right. Let's see. Okay. So I guess we'll just go ahead and get started. If y'all are good with that. Let's see. Let me make sure I got my office hours. Let me make sure I've got everything. I want to make sure I have on my note. So I've got y'all listed for me. And let me do. All righty. Okay, we'll get started. So number 1, the first one that we have is this long division. Like I just said, the first 2 problems are long division problems. I'm just picking 1 of them. It doesn't mean that this is necessarily the one that's on the test, but they work very similarly. So we will work through it. Okay. Let's see. Make sure I got it. Okay, long division. We are dividing x squared plus 2 into that large one. Hey, don't forget when you skip a term like this, you have to put a 0. Otherwise, you get messed up. It won't take you long before you realize you've messed up if you do it. Okay, and we're going to divide into x to the 4th, 0x cubed, x squared. All right. Okay, looks really long. This actually is not that long to work, but just to start, remember, just look at the first 2 terms. And we want to say, what do I need to multiply x squared by to get x to the 4th? And that would be x squared. So let's multiply it out. Multiply it out, we get squared. Okay. So remember, if y'all are writing, I don't know if you're watching or just writing, but when you subtract, that's the same thing as changing every sign, and then you can just add things. Okay, so we have 0 and 0, and 7 plus negative 2 is 5. And bring the x squared down. Okay, so it's subtracted. This one we worked in the homework also. It happened to work out that you could subtract out the first 2 terms. So in this one, bring 6x down. Okay, if we start over again, we have x squared, 5x squared, and we just need to multiply by 5. Right? So multiply 5 through, we have 5, let's see, 5 times x squared, 5 times 0. And then lastly, 5 times 2 is plus 10. So remember, because we have that extra, let's go ahead and bring that 26 down so they match up. So we can bring them both down. One more step, we're subtracting out. So change every sign. So change, 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 and add. We get 0. 6 plus 0 is 6x. And 26 minus 10 is what, 16. Okay, that's our remainder. Okay, the way that Pearson is asking, and they tell you this in the directions, is they want you to write the answer. You bring the remainder up here, okay? You want to write it plus over what you divided by, which was x squared plus 2. That's how they want you to write it. So let me write it neater over here. This is definitely your quotient, right? And then plus the remainder. This is the form they're going to ask you to write the answer, okay? Quotient and then the remainder, right? Okay, like I said, the next one is very, very similar. It's just another one that you can practice on, but you'll only see one on the test. So, everybody good? I'll go to the next one. If you have any questions, please you can speak up or you can type in the chat or something, and I'll do it. Okay, so we're kind of going in order. So this one is the one where you use synthetic division, and it's in the form of find the remaining zeros. So if you remember, since C is given to be a 0, we can use that in synthetic division, and we can factor it. So use synthetic division, C equals 1 is 0. That's what we put here, okay? And then we're going to divide. Okay, and because 1 is a 0, when we finish, it better go evenly. So the remainder better be 0, or you've done something wrong. Our whole goal is to get something smaller we can factor and find the other zeros. So synthetic division, remember, you bring the 1 down to start, and we multiply and add all the way down. So 1 times 1 is 1, and add. Okay, 3 times 1. So you're multiplying by that every time. 3 times 1 is 3. Add. 2 times 1 is 2, and you add. All right, so it worked. So that was the remainder. Remember, remainder. Okay, and it should have been a 0. This is my quotient. So this is what we have. Let's put the x's back into it. We have 1 x squared x plus 2. Right, and that's what it went evenly into. This is what my quotient was. So to find the remaining zeros, all we have to do is factor this, and set it in and set each one equal to 0. So it ought to be able to factor pretty easily for you if you have a problem like this. I mean, I haven't seen any that are really big and complicated, so plus and plus. All right, so your zeros. You can look at it and tell, but remember, you set it equal to 0 and solve. You get -2. And same thing for this one, you get x equals -1. All right, so your answer, the remaining zeros are -2 and -1. If you happen to list all of them, like 1, like that, that's the 0. Those are the 3 zeros, right? If you listed all 3 of them, they're going to count it off completely. But I would give you credit. But all they're asking for is the remaining. So if you can remember that, that'll just help because you won't get counted off in the beginning. So okay. I think that's what we use the synthetic division for, is to find the other zeros. All righty. I am recording this too in case I go a little fast, but just let me know if you need, if I go through a little too fast. Okay, I want to make sure there's 3 asymptote questions on the review. I'm going to do each one. Please don't overlook the vertical and horizontal and slant asymptotes because you're going to have more than one question of these on the test. So if you overlook it and miss them all, it could really hurt your grade. So I wanted to go through all of them just because there's different situations that could happen. So for the first one, they're going to give you a function. They're going to ask you vertical asymptote for the first part and horizontal for the second. So let's do the vertical asymptote. Okay, so I'm going to rewrite it a little bit bigger for me. Okay, so for vertical asymptotes, remember, always see if it can be simplified first. That's really important, and you do that by factoring just to check. This actually factors top, and this factors 3 times 2. So they both factor, but there's nothing left to cross out because you have x plus 3 and x minus 3. So you really can't simplify it at all. So it is simplified. Okay, so your vertical asymptotes simply are what make the denominator 0, not the numerator, just the denominator. So we set each one equal to 0. That's 1. And you get -2. All right, so we have 2 different vertical asymptotes right there. All right, so up here you would type in A and you would write x equals 3, x equals -2. Make sure, please, please, please make sure you have x equals. It's very important. Don't just type in 3 and -2. It has to be the equation of a line, and the equation of a vertical line is x equals. Horizontal is y equals. That's really important. Okay, so don't forget x equals. All right. Okay, so the second part, let's do the horizontal asymptotes. Okay, this is the one, if you remember, I'm going to recopy again my original function. As long as you know what you're looking for, you can answer this thing really, really quickly. So for horizontal, if you remember, you just look at the leading terms right there, and you look at the exponents. So you've got x to the first in the top and x squared in the bottom. Remember, if it's larger in the denominator, it's equal to 0. Y equals 0. That's if it's larger in the denominator, and that's because it was. So as long as you know what you're looking for, it's always y equals 0. That's your horizontal asymptote. So it look like that.
I have a question. Is it always going to be the first term in the asymptote?
Yes, it's the leading term. So if for some reason they were out of order, you want to make sure you pick the highest term. But the ones we would see, though, I think are in order. So, yeah.
Can you explain that one more time?
Okay, so you look at the leading terms, the 3x and the x squared, and that just means they're the ones with the highest exponent, you know, in the top and the bottom. You look at the little exponents right there, okay? And there's 3 things that can happen, right? And in this thing, they give you 3 different examples. So the next 2 are going to be the different examples. They could either be the same, which they could be like x squared over x squared, which is, this is not. It could be larger in the denominator, which is what this one is. And if that happens, the horizontal asymptote is y equals 0 every time. So as long as you know what, and you have it in your head on what it is, you can answer it within a few seconds. So when I looked at this and I saw that it was squared in the denominator and it was only to the first power in the top, I knew that it went to 0. And that's horizontal. Okay? If they had been the same, let's just say that this function said 3x squared over x squared, then you pick the numbers that come in front, 3 over 1, right? That's if they're the same. And then the other example would be if it's larger in the top. So if it had been like x cubed in the numerator over x squared, there is no horizontal. So 3 different possibilities, and it all deals with the exponents. Okay, so this is the first one, and what the next 2 examples show the other situation. This is the one where it's larger than the denominator, and it equals 0. Y equals 0, kind of important. Okay, let me show you. Let's do the next one and see if it Makes sense. This is all, that's with the horizontal. Okay, for this one, it's the same thing. Oh, it's not. Hold on. Sometimes it gets frozen, so let me redo it. Sorry, I have to share it again. It's not erasing when I'm doing it on my thing. So hold on. Sorry. All right. Good. All right, here's the next one. Okay, so for vertical, the first one. Remember, it's just the denominator. All right. Okay, now the top can be, it could be factored, but nothing crosses out here. So this is simplified. To your vertical asymptote, just set the bottom equal to 0 and solve. So that's my vertical asymptote, would be x equals 1. Okay, that's the vertical. And let's do the horizontal. Okay, so this is the next situation. So remember, horizontal asymptote, you look at the leading terms, the ones with the highest degree. So that would be x to the first and x to the first, right? So you're looking just at these two. All right, so since the degrees are the same, what you do is you just take the coefficients in front. So that would be 4 over 1, which is 4. That makes sense? So my horizontal asymptote is y equals 4. Does that make sense? So those are two examples where you actually get a horizontal asymptote. So good. So that's when they're equal. All right. So those are those two. And then one more. The next example is that third thing where there is no horizontal, but there happens to be a slant. So I wanted to work that one also. So once again, you just want to pay attention to these because there's more than one of these on the test. And they're pretty easy to find as long as you know what you're doing. So, and once again, you're allowed your notes. So make sure you can have some good notes with you so you can follow along and help you there. Okay, one more. We'll do vertical asymptotes first. Once again, it's kind of small, so I'm going to recopy. This one, definitely see if you can simplify, right? So I'll do that, see if it factors. I think it does. It actually factors. But just like the last two, it didn't help us at all. There's nothing to cross out. I'm actually surprised we haven't put one on here that you actually can cross out. Might even look into that in the future of changing it, but it never, because you're supposed to simplify if you can. But this one you can't. So just like the last two, it's almost the same. Just set that denominator equal to 0 and solve. I've seen people, I'm sorry.
Will it be one on the test that we can cross out, or will it be like the homework?
I don't think so because they're very, but don't quote me on that. You could get one that actually could be, but everyone that I've worked so far on the review has not been that way. So chances are really great that you won't be able to, but be aware of it. You never know. There's a generated test, and you could possibly get one that actually crosses out. So I just don't know for certain. But chances are great you probably won't. So, okay, so that's that one. I've just seen people in the past that want to set the numerator equal to 0 also and list like 3 different asymptotes. Make sure it's only the denominator. It's for the vertical asymptote. All right? Okay, so that's the first one. Okay, so for the next one, just for time, let's see, we'll put it right here. For the horizontal asymptote, right, you're just looking at the leading terms. Okay, and in this case, it's this one and that one, right? But this time, like it's 2, the exponent is 2 over 1, so it's larger in the numerator. When this happens, there is none. There is no horizontal asymptote. Okay. Right, that would be B. The function has no horizontal asymptote, but it does have a slant. And the way you can tell it has a slant asymptote is if the exponents are 1 more than the denominator. So like it was 2 over 1. It only differed by 1. If this happened to have been x to the 5th over x to the 1st, there's no slant asymptote either. But when it differs by 1, you actually have 1. So this one does have 1. And the way you find it is you're just going to actually divide this fraction. You're dividing, what is it, x plus 1 into, all right? So you're going to divide, and it's just a little short division. The quotient is your answer, and it's going to be in the form of y equals mx plus b, which is a line, right? So, and you could use synthetic division on this if you wanted to also. So just quickly, x goes into 3x squared. You can
So I have a question. Does it have a slant asymptote only if the top term is 1 degree higher, or if the denominator was 1 degree higher, would it have a slant asymptote as well?
No, only if the top is 1 higher. Like you can't have a horizontal and a slant. They never both exist.
Okay.
So if it was larger in the denominator, then you would actually have a horizontal asymptote and it would be 0. But the slant only happens when it's just larger in the top.
Okay, thank you.
Good question. Yeah. All right, and so you say this goes in 3 and we need an x, right? So let's multiply it out, 3x squared, and then plus 3x. We just have to subtract really quickly, so change our signs, negative and negative. And when we add, we get 0, and negative 5 plus negative 3 is negative 8. And bring down the negative 2. And then you just do it one more time. X goes into negative 8x, negative 8 times. Okay, so you're actually done here. That's my answer. If you want to finish working it out to get the remainder, that's perfectly fine, but the slant asymptote has nothing to do with the remainder. It's only the quotient. Whether we get a remainder or whatever, that doesn't matter. So you really could stop here. Your slant asymptote is y equals 3x minus 8, which is a line, right? It's a slanted line because it has a slope of 3. And that's it. Question? That makes sense? You certainly could go ahead and finish it out if you want to, but for the slant asymptote, you don't have to. All right. Okay, so those are 3 examples of the asymptotes. Okay.
Will we ever have an example where it's no horizontal asymptote as well as no slant asymptote?
You know, I'm not sure, but let me show you an example just to show you.
Okay.
In case you know. If it's okay, I'll just put it up here. If I gave you a function like 3x to the 4th, something like that. Okay, there's no horizontal, right? Because the 4 is larger than the 2, so there's no horizontal, right? But there's also no slant.
Because it's more than 1 away.
Yep, because it's 4 over 2. But if it had been like 4 over 3, then yeah, there is one. But this one doesn't have either.
Okay.
That'd be an example where you see it. All right. Okay, hope that makes sense. All right, so I wanted to definitely go through the polynomial inequalities. It's kind of weird on this because it seems like this is just thrown in the middle of doing other stuff. So, but you definitely, if any of y'all are moving on to calculus, it's just there are times where you're going to have to use the number line, so it's good to know how to do it. So let's work these, the polynomial and the rationals. Okay, when we're solving these inequalities, this is where we're going to make the number line. But before we start, we need to have 0 on one side. So I'm going to subtract 64 over and get less than or equal to 0. You always start that way. And then you want to factor it. Okay, and this factors to x plus 8, x minus 8. Right. It's nice if it's already factored for you, but this one, go ahead and factor. To find your boundary points, set it equal to 0 and solve. So this would be, you know, x equals -8 and x equals 8. These are, we call them boundary points. They're basically the values that you're going to plot on your number line. -8 and 8. Makes sense? So make sure they're factored. So those 8 and -8 are the two values of x that make this function equal to 0. All right? And we're actually solving for less than or equal to 0. So 8 and -8 are actually part of the solution. So this is where I like to teach it, where you do straight lines and dotted lines. I'm going to draw straight lines to separate the intervals. And once again, the straight lines are because I'm trying to solve less than or equal to. The equal to part means a straight line. If you watch some of the other videos, he uses little closed dots, but that's the exact same thing. A straight line and a closed dot represent the same thing. And all that means is when you write your answer, you'll put a bracket in interval notation. So, okay, just one thing real quick. If the original problem had been strictly less than 0, then you would have put dotted lines. So that's the difference. But when we get to this part, we have 3 intervals. All you want to do is you just want to test an interval, test a point in each interval. So like between -8 and 8, you could use 0. That's nice and easy. Let me write this down again. This is what we're plugging into. X plus 8. I like to use the sign chart, right? So it doesn't matter what order. Like if we chose something less than -8, like -10, if you plug -10 into here, okay, you get -10 plus 8 is -2. And then times -10 minus 8, that's -18. Two negatives multiplied together give you a positive. So that whole region is positive. And then separately do it again for 0. If you plug 0 in, you get 0 plus 8 is 8 and 0 minus 8. So positive times the negative is a negative. There. And let's see, 9. Just something over here. 9 plus 8. 9 minus 8. 2 positives. And there you go. So you test it. This gives you the answer for everything. Just a little hint to y'all. When you have a function that when it's factored, it's just a bunch of factors to the first power, like it is here, x plus 8 to the first, and x minus 8 to the first. Your positives and negatives alternate. Okay. Now it doesn't always happen. Like if I had thrown in like a squared or something, things don't alternate. Okay. But when it's just to the first power, it alternates. It's just kind of nice to know. All right. But regardless, let's finish it. We're looking for less than or equal to 0, which less than 0 is a negative number, which means that's my region. And then we're going to write right there. This is my region of my x's. So we write it from -8 to 8. The straight lines meant brackets. And there's my answer. 0 to 8. Okay, if I had asked for greater than or equal to 0, then I would have listed the 2 positive intervals. So this is the only one. Okay, so this is one where you actually had to bring the 64 over and factor it first. The next one is very similar, but it's already factored for you. See, so it's already given to you factored, which is nice. So you basically just need to find your boundary points. there. So set each one. Don't forget the first one. X equals 0. There's 1. And if you set that one, you get -3/5. So those are my boundary points. It's very similar to the last one. You have -3/5 and 0. Okay. All right, similar to the last one, we're looking for less than or equal to 0. So straight lines. Oh, sorry, that's not good. 0. Okay. Test our 3 regions. Okay, let's start over here. Something less than -3, we could do -1 or -2. Remember what we're plugging into. X times 5x plus 3. So we have -2 is the first one. And then 5 times -2 is -10 plus 3. Negative. 2 negatives give you a positive. Okay, so now remember what I was saying, when you have when you look at your function and it's just 2 different factors to the first power, it alternates. Okay, so I can look at this and tell, I know it alternates, it's going to be positive, negative, positive, but you might want to be just careful and check it just to make sure. Okay, okay, something between 0 and -3/5. That's not quite as easy. I'm going to pick -1/5. That's smaller. If you plug it in, you get -1/5 for the first one. And then if you plug it into this 5 times x, you get what, -1 plus 3, positive? Negative. And then if you pick 2, you get positive. And then 10 plus 3 is positive. So it alternated again. All right. We're looking for less than or equal to 0, which just like the last time, turned out to be a negative. So my answer, I'm running out of room. Sorry, I'm scribbling up here. We'll say it goes from -3/5 to 0. Both of them are straight lines, right? So that's my answer. Straight lines mean brackets. Okay. All right. So there's 2 of those, just 2 different examples. They're kind of similar though, but of the polynomials. All right. Okay. Let's do one more, and this is the rational. So expect to see one of these for sure. One of the rationals. And if you notice, it's probably the easiest kind you could see, okay? Because you don't even have to factor or anything. All right, so let's work it. It's worked the same way. All right, so to find your boundary points, you just set the top and the bottom equal to 0. So I'm just going to scribble, if I set x plus 6 equal to 0, I get -6, right? That's 1. And the bottom would give you 4. So my boundary points are -6 and 4. That makes sense? And I'm just going to right here, 6 and 4. All right. So the only difference is we're dividing positives and negatives instead of multiplying, but it's the same rules. Okay, this is the part that over 50% of the class usually misses this. So please pay attention. And it all deals with the dotted and straight lines. So the bottom, let's see. The one that makes the denominator 0, the boundary point, is always dotted. So if you're writing notes that you're going to use when you are taking the test, remember the denominator, always dotted. And the reason is, if I were to plug 4 into this function, I would get 0 in the denominator, which is not defined. So it can never, ever be a part of the solution. So we draw a dotted line, okay? But the numerator is different. I can plug in -6 and get 0. So the top one depends on whatever I'm asking for, and this said less than or equal to. Most people will miss it because they'll see the less than or equal to and draw straight lines for both of them, okay? But if that denominator has a straight line on it and you put a bracket, you've missed the problem. So does that make sense? This is what, for all these years that I've taught college algebra, this is the part that most people are like, now why is that dotted? And it just simply means if I took 4, let's say I plugged it in here, 4 plus 6, and 4 minus 4, I'd get 10 over 0. And that makes no sense, okay? That's why we do a dotted line, okay? All right, let's, real quick, let's test it and get our answer. So something between here, I'll pick 0. We're plugging it into x plus 6, x minus 4. So if I plug 0 in, I get 0 plus 6, positive. 0 minus 4 is negative. So positive divided by negative, it's negative. I just started with the middle one for no particular reason. Okay, it does not matter which one you start with. It's the easiest because you can plug in 0. I'll pick something negative 8. If I plug it in, negative 8 plus 6 is negative. Negative 8 minus 4. So 2 negatives give you a positive. And finally, if I plug in 6, I get positive divided by positive. Okay. So for this review session, this assignment, randomly, each of the last 3 problems has been positive, negative, positive. That's not always the case. A lot of times it could be a different order. So, but I'm looking for less than or equal to 0. So once again, the negatives. So my answer is negative 6 to 4. Be careful. Bracket, right? Because the straight line. Parenthesis, because of the dotted line. That's my answer. Right? So those are the inequalities. So really 3 different ones you just kind of have to study and figure out.
I have a question.
Yeah.
It's since you're asking for less than or equal to 0, is that why the answer range is just the negatives because it's only less than 0?
Yes. The negatives less than 0 just means these negatives represent negative numbers.
Okay.
And numbers are less than 0. Yeah. So
Thank you.
I will say, if this for some reason, okay, had been greater than or equal to 0, you would have worked the same way. It's my answer would have been these. Okay. Because positive numbers are greater than 0.
I don't know, just hypothetically, like how would you write that on a test if it was like asked? Would you have to like do like included or something?
Yeah, if it was greater than or 0, right? If it happened to be and I was doing the positives, it's 2 different ones. So the first one over here, right there, would be negative infinity to negative 6 bracket because of the straight line. Then you have to skip over that middle one. So they want you to put a union, a U,
Yeah.
and then you do 4 to infinity.
All right, thank you. I got it.
Yeah. So that's how you do it. That's only if it was positive. Greater than, I should say. All right. Okay. So that was all 2 weeks ago. That was that first week. And then now the rest of the material on this is from last week with logs and exponentials. So we'll go through these. These all go together. So I'm working through these. First, evaluate the log without the use of a calculator. Obviously, we're not supposed to have any kind of graphing calculator or scientific calculator. So, but is there a way to solve it without a calculator? And I went over these shortcut properties. There's 2 ways to approach this, and I'll show you both. Both of them are completely fine. Whatever you look and think might be the easiest. So for the first one, we have the shortcut. See, if 27 is 3 cubed, if you can rewrite it where the bases are the same, 3 and 3, then whatever that exponent is your answer. Right there. It's just randomly. But let me show you, that's the shortcut. There's another way of looking at it, and you can say, if you want to solve it, you can set it equal to x, okay? And then you can convert to exponential. So if you start with the 3, and you do this, this counterclockwise circle, 3 to the x equals 27. You can solve it that way. 3 to the x equals 3 to the 3. Since our bases are the same, then I can assume that x equals 3. Look, that's two different ways we went over it, but it's the way you can solve it. Either way that makes more sense to you gives you the same answer. But the shortcut thing right there, if you can recognize it, is the closest thing. I mean, it's the quickest thing. And there's another one. This was the next one on the assignment. It's very similar. Let's see, the square root of 3, you can rewrite that as 3 to the 1/2. And this is just very similar. These are two random problems that came up that both had the base of 3, okay? They just happen to both. But if you have the same bases, then it equals 1/2. Boom, just a very quick little shortcut way. Most cases with logs, you'd have to type it into a scientific calculator and your answer is a decimal. We're just dealing with ones that you can actually get a whole number or a fraction. So those are just quick answers that they want you to solve. And once again, these are the directions without the use of a calculator. So just look for shortcut methods.
Is there another way that you could do the one that has the radical in it, or is that the other way?
Let me show you that. That one, very similar. So if you had, and you're wanting to know what this is, right? Once again, set it equal to x and then solve it for x. And once again, when you have it this way and you've created a little equation, and what you have to do is you have to convert to exponential. Convert to exponential. And so you start with the base. 3 to the x equals that. Equals square root of 3. And then you use the relating the base. If 3 equals 3, then x is 1/2. That makes sense there? Just kind of a different way. It's a couple more steps, but
So if it was 5 and 5, it would have been 1/2 too.
yeah, like if you had just showing y'all, I'm throwing it. If I had log base 5 of 5 to the 1/2, these have to be the same, and 1/2 is my answer. So you can't do that shortcut if the bases are different. So it has to be log base 5 of 5 or log base 7 of 7, something like that. Shortcut. I think there's one that shows up in a little while, another one that's similar to that, and I'll show you. That's okay. Let's see. It's this one. Okay, this is wanting you to expand the log. So the next few problems are expand the log, and then they're going to turn around and ask you to condense it into one. So for this one, I wanted to include this one on here because if you were working one like this, before I even started to expand it, I would go ahead and multiply the 1/256 times x. Okay, that'll just make the problem much easier. And if you go ahead and do that, and you multiply it, you can rewrite it as x over 256. I promise you, that just makes it so much easier. Instead of dealing with 1/256 times x. Go ahead and multiply it. Now they want you to spread it out, expand it. And so remember the rules. If you are dividing,
We
Sorry.
multiply what again?
Sorry, can you say it again?
What do we multiply again?
Oh, I multiplied right here x times 1/256. And I got, x on top, 1 times x in that case. It looks kind of weird, but if you think about it, 1/256 times x is like an x over 1. When you see it, it's just never written that way. So you can get x over 256, like that. Okay? And so when you do that, you could combine it pretty easily. All right? So when we come down here, we have the log base 4 of x. And because we divided the terms, we subtract between the logs. 256. And it split them up into 2. Remember, the division, 1 divided by 256, when you split them into 2 logs, you subtract, right? You don't divide, you subtract. And you think you're almost done here, but they do say wherever possible, evaluate the log expressions. That's code for if you can figure out if one of them actually can be written as a nice number, do it. And right here you can. We obviously can't do anything with that. But this is that shortcut method again. 256 is 16 times 16. So you can rewrite that in times of 4. That's 4 to the 4th. It happens to be. And so that shortcut method, since we have base 4s, that equals 4.
If we just wrote log 4 to 256, would that still give us the correct answer, or would we have to say -4?
They want you to simplify it. They would count off a little bit for it. So if you can write that down in your notes and expect it, because if you get this problem, it'll probably give you something over here that you can simplify. And you would, I don't know if they count the whole thing off. I know if I went back in, I'd give you definitely some credit for working it, but not all of it. So they're wanting you to recognize that and see if you can find the number. So, anyway, so yeah, just another little example, If you ended up having, I don't know, log base 3 of 81, something like that, you just ask yourself, can I rewrite 81 in terms of 3? You can. 81 is 9 times 9. So that is 3 times 3 times 3 times 3. See, and since the 3's are the same, this equals 4. Right? It's just kind of that little shortcut method. I mean, in all reality, when you're dealing with logs, there's not a whole lot of times that this will happen, but on this test, they're going to come up with some problems that ask you to do that. So just kind of be looking for it. It won't be a ton, but you might see it in 1 or 2 problems.
So the answer is just 4.
Oh, sorry. That's my answer. They just want you to expand it. So this will be, expanded out. They just wanted you to convert that second log to 4. And that's what they want. Okay.
So we write that whole equation right there as the answer.
Yes, you have to type it out. None of these are asking you to solve it. They're just wanting you to expand it. So it'll be written as like log plus or minus a log. So now the next section that we covered is when you actually solve like an equation. But this is they're just wanting you to expand it. That one. I think the next one's that way. Let's see. Yeah, this one they're asking you just to expand it again right there. So when you expand this, just using those properties, this was all from like 5.3. All right, we've got natural log of a to the 6th, and because you were multiplying times b, right, you're going to add between the two. That. And then because you divided by c to the 8th, you subtract. That makes sense? That was that rule. This is when you're wanting to do it into different logs. Just remember, multiplication doesn't translate to multiplication. It's like if you're multiplying the 2, you add between the logs, and then division is subtract. And then for this, it's expanded, but they want you to take it one step further and bring the exponent down in front. So the answer would be 6 natural log of a. And that is all they're wanting for you to do, just to show that you can expand it. All they're wanting. All right. Okay, so that's 2 that are expanded. And then they turn right back around and go backwards. Okay, they want you to condense it. So the next one would be, there's 2 of these. This one, you have a bunch of different logs, and they want you to combine as a single log. That's all they want you to do. So hopefully, if you remember this from your homework, this has a particular look to it. Definitely a particular look. So if this does come up on the test, hopefully you can recognize it, that it's the same kind of problem. And it really is very, very similar the way it's worked. All right, so if we're going to combine it, now look, if you wanted to, you could switch these terms around to make it a little bit easier for you if you want to do that. But this is what I would do, I'd say. Okay, I have log base 7. I'm combining into one single log, okay? And I have x squared minus 7x plus 10. All right, because of the subtraction right there, you divide the term, right? And then the big question is, what do I do right there? Okay, because of the plus. Where do I put it? Do I multiply it in the denominator or the numerator? Well, since they're not particularly grouped together, if you see the plus, that's meaning they want you to put it up here. Okay. Let me show you a little. I'll erase this. The only reason you would have put x plus 2 in the denominator is if I had had this thing grouped together, then you would have subtracted, you would have multiplied them first and then divided. But it's not written that way. So if you can just remember, if you see a plus, you put it in the numerator. If you see a minus, you put it in the denominator. And then things should factor and everything should cross out and give you a nice, simple little plain answer. So let's definitely try to factor. And it does. All these factor. All right, the first one. Times 2 is 10. And then the bottom is the difference of 2 squares. So look, expect if you see one like this, it should factor nicely like this. They're all different numbers, but the same kind of problem. So it should look very similar. So my answer is log base 7 of x minus 5. That's what it looks like. So you combined it into one log. But none of these answers are going to be real big, huge, complicated logs. So it factored. All right. Please don't forget to put the log. In the past, I've seen people that did everything right, and when they wrote the answer, they only put x minus 5. And if you don't have the log base 7, because that's what they're asking, write it as in a single log. If you leave that off, you get the whole thing wrong. Okay? Very important. It's a log. Okay? All right. Here's one more really quickly. Combine into a log. And this is natural log, but you treat it the same. So we're just going backwards. So first step, let's bring these numbers in front, bring it back up. We're just reversing the order. So you can rewrite it. Squared. And then minus, going backwards. And this is what I was just kind of talking about. Now that you just have a bunch of natural logs being added and subtracted, you can combine it into one big natural log. The plus means you multiply the terms. Subtraction means you divide. That's all they're wanting. And I just in the past have seen so many people that are working it right, but don't put the log. They only list the x squared y cubed over z. And if you don't have the natural log in front, you've missed it. So that's what they wanted. Okay, so this is just giving you a couple of problems since it was one of our sections. All right.
Can you stay on this one just for like 5 seconds? So
Yeah, just you can write. I'm going kind of fast. Sure. Just let me know when you're done. I'm good.
I'm finished.
All right. Okay, so those were all of the combining and condensing. So now we get to the last section. 4, 5, 6. Okay. This is where we're solving equations. Okay. So there are two kind of exponential equations and there's two kind of log equations. The log that have the logs in it. So here's the first one. We actually covered this in section 5.1, but they're kind of grouping it here. This is an equation. So if you're solving an exponential equation and you can actually relate, it doesn't tell you to relate the base. Relate the bases. That means if you can write this in terms of the same base, that's probably the best way to, the way that we're wanting you to solve it. So let's do that. Okay, we have 25, which is 5 squared. Just rewrite that. Okay, and then we have what, 1/5. I'm gonna rewrite it. Yeah. Okay, we want, this is 1/5. We want it to be 5 and 5. So remember, you can bring that 5 to the top by making it 5 to the -1. So that would be like that. So it's now 5/1 instead of 1/5. Just change the sign. But we do have both 5s, which is what we want, right? So now let's rewrite it. When you have a power to a power, you have to multiply that through, right? So that would be 5 to the 2x. That would be -1 times x, and -1 times -3 is +3. There. So your goal is to get it written in this form where your bases right here are the same. All right, so since 5 equals 5, we can assume 2x equals, and then you just solve a basic little equation. Okay, I'm gonna add x to the other side. Run out of room. I get 3x equals 3. Oops. Wrote too big. Okay, sorry, and you get 1. Divide out. Okay, that's kind of relating the bases. And that's the what we covered in 5.1, at the beginning of the week. All right. So I'm gonna move on to the next, if y'all are good with that. Okay. Here's another one. It doesn't tell you to relate the base. You have a question? Okay.
Oh, no, excuse me. I just joined the call, so it was unmuted.
Oh, okay. Just making sure. All right. So for this one, I solved the exponential. If you can rewrite it, which I can, 16 is 4 squared. 64 is 4 cubed. So pretty simply, you can say that's 4 to the 2x equals 4 cubed. And since you have the same bases, you can, it's kind of like dropping the bases and just set those powers equal to each other. And there you go. X equals 3/2. So that's a nice quick one. So yeah, once again, if you have the same bases right there, then you can just set those equal. Then like that. Okay, 2x equals 3. That probably made it look weird. Yeah, I'll get rid of that. Okay, so there you go. All right, so those were 2 where you relate the bases. That's what we did in 5.1. Okay, that's the first exponential kind of equation. I think we skipped, we're going to do a few logs in the order of this, and then we'll come back to the other exponential equation is when you can't get the same bases. Okay, so let's do that. Okay, so here we go. We're going to do the log ones first, and then we finish up with the other exponentials. Okay, 2 kind of log equations you'll see. This one is when you have log equal log. So there's logs on both sides of the equal sign. This is actually kind of nice. You know, to solve a log equation, we have to somehow get rid of the log. We've got to. So you're either going to convert it to exponential or you can drop the logs. This is an example of one where you can drop the logs. Because you have log on both sides, and since I know both of these are equal, then you can drop them and just set x minus 5. And then solve. So nice and simple. But that only happens when you have logs on both sides, like everything is a log. You can drop them. So it'd be what? there. And then plus 5. We got 7 equals 2x. I got 7/2. That's my answer. 7/2. So that's the one, I think it's the only one you would see where the logs are equal to each other. Just drop the logs. All right. Okay, so that's the first kind of log. The second is when you have to convert to exponential, which we did in some of the other equations. I mean, some of the other sections. So let's look at number 17. We just got 3 more problems, okay? Here's the, this is the other one. So if you notice, this is different because this got log base 3 equals 2. So it's different from the last problem because it's not log base 3 equals log base 3 of 2. So you can't just cross out the log. You have to convert, right? Convert to exponential form. Exponential form. And remember how we do that. You start with the base 3 and you do 3 to the 2 equals, you just do a counterclockwise. 3 to the 2, 4. So just make sure you don't just drop it and get, 5x minus 4 equals 2. That's wrong. But you're left with something nice and simple, pretty easy to solve. Sorry, I'm going to add 4 over. That's what, 13? I get x equals 13/5. That's my answer. So convert to exponential. 3 to the 2 equals 5x minus 4. So those are the 2 kind of logs that you'll see. Convert. And once again, the way you know you're looking at it, if you look at the original problem, if you have log and a number on the other side, you have to convert. But if you have log equal log, you can just drop the logs. All right. Let's see what we have here. All right. This one, we're back to the exponentials. This obviously, you can't get the same base because 9 is 3 squared. So when you can't get the same base, you're forced to take the natural log or the log of both sides, and it doesn't specify. So you could have done natural log or you could have done log. Doesn't matter. By taking the log of both sides, now I can bring x down. That. And then finally, this is just a number, so natural log of 9 is. You can divide out. And that is what they're looking for. In the homework, remember they wanted you to take it a second step and type it into the calculator and get a decimal. But since we don't have calculators to do that on the test, no decimals, right? So that's all they're looking for, right? Perfectly fine. And you would have gotten it correct if you had written as log of 2 and log of 9. So both of those would have worked. I like to write natural log, especially the next problem when you do with ease, you want to use natural logs. So I use natural log a lot. Okay, but that's all they're looking, that's the solution. Okay, and the last one we'll do, and we'll be done. It's just another one, e to the x. So the way you do this is let's clear that 3 out to the other side by dividing, right? Because you don't want to take the natural log unless it's just e. So number 3. And so now you can take the natural log. You definitely want to do natural log of both sides. Because the natural log of e, if you remember, a natural log is an understood base e. And once again, that shortcut method, they cancel out and it just equals x. So it's a quick way to just get x. And so you have natural log of 32. I guess you can put those in parentheses if you want to. but that's your answer. All righty.
I have a question.
Yeah.
Where did the E go?
Yeah, this was the natural log of E. These canceled. Remember that? Remember how we had like log base 3 of 3 squared? If you have the same bases, it just equals this. This is the same thing because natural log is base E. It's just never written that way. So the natural log of E actually, it crosses out and just gives you X.
Okay, so E is like the base root of natural log.
Yes, definitely. And it's just never written, but that's what the base is.
But it's just like a given understood kind of thing.
Yes, it's understood. Just like if you ever see LOG, like the one that's on your calculator, that's an understood 10 base. It's just never written that way. And then natural log is an understood E. They're understood, they're never written. So I will show you on this, it's a shortcut, but look, when you had right here the natural log of E to the X, like you can bring X down in front. The natural log of E equals 1. But I personally think if you can just remember this little part by the shortcut method, that's the quickest way. The natural log of E, it crosses out and just gives you that power, which is X. To me, that's the best. All right. Okay, now once again, I didn't work. I think there's 22 problems on the review and we've worked 19. So I did work all of them, but I worked most of them. And I hope it helps. Remember, I emailed y'all and I posted in the folder for this week another video of me working out a review assignment. It's the same problems, different numbers and stuff, so they're different examples. So if you wanted to work through another one, you could work through that one also, and just see if you can work it. It's, like I said, very similar but different actual problems. All right. Any other questions?
I have one question. Do you know how many problems are going to be on the test?
Okay, I think there's 19, but I'm gonna try to write an email today to all of y'all telling you that. I need to get all my facts in order. I think there's 19.
Okay, thank you.
Okay.
The test is available for us to take now.
No, it becomes available tomorrow morning on Wednesday morning, and it's done. You just have to have by midnight on Friday. So
What were you saying about another review? You said it's another review or something?
Yeah, I emailed y'all earlier, but I also posted it, like on the weekly assignments. Let's see, I'll do that. On the weekly assignment folder, I think I posted it, and it's a video of me working out. I was just sitting here by myself and working out one, similar to what we just did, but it just was different problems.
Okay, so it's more questions over the whole test again, basically. You were working out.
It's kind of what we just did, except I was just sitting by myself working it out. So if you wanted another one, you could, write it down, work it, and then, then hit play and see if you got the right answer. It's another way that you can kind of check. And working through it. And I'm going to have another one of these tomorrow morning, but I am going to be working through the exact same problems. It's the same one. So you're welcome to join me again if you want to, but it'll be the exact same. All right. Okay, well, if there's not any other questions, feel free to email me. If not, that finishes off today.
Thank you so much.
Sure. See you later.
Right there.